Hi there. So far in this series, we've done side, 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 side angle, side angle, side angle. And today we are going to do angle, angle, side, triangle congruency theorem. Let me show you how that works on paper. Okay, I got an angle, angle, side in that order. It's not the side that's between the two angles. This one looks really obvious, right? But let's just double check it. So go that way and go that way, and I get a triangle where there's another vertex right there. Okay, let's check. Not even using a ruler this time because I want to go faster. Okay, that's pretty good. Same triangle. No, the suspense. Yeah, it is. So this combination also forces two triangles to be congruent. And this one is the angle, angle, side combination. Angle, angle, side. Where the side is not between the two angles. That will also work. Let's look at the examples so you can recognize it. These two triangles are congruent by angle, angle, side. And when they're marked up, this is what it's going to look like. Angle, angle, another angle, angle, and then a side. The thing about this one, the side is not in between the angles. You go from angle to angle straight, 1, 2, and then a side. So we go from angle to angle and then down the side. AAS, AAS. Look at this one. Angle, 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 and then the side is the one that they're sharing. It's not the side that's between the angles. It's angle, angle, side, angle, angle, side. Now here is interesting because we have vertical angles. Remember, that's a definition. Nobody needs to tell you that those are congruent. You know that they are. So we have angle, 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 and then there's our side. Angle, angle, side, angle, angle, side. Now here's the one that isn't going to work, so you can compare it to the ones that do. I have two pairs of congruent sides, which is great. But in order to use angle, angle, side, you actually need to know some stuff about the angles. And here I've got nothing. So we're just going to have to go with not enough info to use angle, angle, side. It doesn't mean that these two triangles aren't congruent. It just means that you're not going to get at it using this congruency theorem. What additional information is needed so that we can use angle, angle, side? So I've got two sides that are already marked congruent, and remember, vertical angles are a freebie. Nobody needs to tell you that they're equal. We already know they are. In order to get this, you have to get another angle. It's going to be either this F and X, or it's going to be the H and the V, and some of you are watching going, you know exactly which ones. But just in case, if you choose this one, what you're getting here is angle, side, angle. Angle, side, angle. Angle, side, angle. Of course, that's a lovely theorem, but that was the last video. We want angle, angle, side, so let's not use that one. We want these over here. So angle H has got to be congruent to angle V if you're going to use angle, angle, side. Let's do it again. We want angle, angle, side. These are the angles I'm going to need. I don't want the side to be in between my angles. I need angle W and angle E. And then somebody out there is going, no! Because there's actually two answers here. The other set of angles will work as well for that. If I just look at the green angles, I would have angle, angle, side, angle, angle, side. So I can go with another pair here as well. All right, let's look at the proof. I'm going to use angle, angle, side on this one. Again, when I'm done showing you all of these individual congruency theorems, I am going to make a video where we mix things up when you have to do proofs when you don't know ahead of time what it's going to be. Hopefully you're learning how to do proofs as we go. Now make sure the first thing you do is you mark your diagrams. So we have angle E congruent to angle H. GH is parallel, that's what that mark means, to EM. And I already have those marked on here. But whenever you see parallel lines in a triangle proof, you are looking for something like alternate interior angles, because here's two parallel lines and a transversal going down this way. I'm not drawing it in for you. Imagine it. So where are those? They're here. Alternate interior angles. See what I've got? In this top triangle, I have angle, angle, side. On the bottom triangle, I have angle, angle, side. So that's going to be the theorem that we use. Let's start filling out the proof. Angle E is congruent to angle H, and we know that because they had to tell us that. There's nothing else in the diagram that would tell me that. And so that gives me my first angle. The next thing I've got to get into this proof is that these two lines are parallel to each other. That's also given. But I have to have that because I can't talk about alternate interior angles until parallel lines are in my proof. So now I can talk about those angles being congruent. HGM is congruent to EMG. Not going to lie, I had to think about that a little bit. And we know that those two are congruent because alternate interior angles are congruent. You are not allowed to say this in a proof unless you've established that the two lines are parallel. And it's not established just because someone can see it here. You have to put it into the proof so someone reading your proof knows that's what you're using. I know this is true, so I can say this. And that is our second angle. And now we need the side, which is angle, angle, side. And the side is actually pretty easy. It's going to be the reflexive property again. And segment GM is congruent to segment MG by reflexive property. We now have it established, angle, angle, side. So we can say that the two triangles are congruent. Triangle EGM is congruent to triangle HMG by angle, angle, side congruency theorem. Angle, angle, side is complete. There's one more left to do, and that's the hypotenuse leg. That's coming up next. I'll put a link to it here, and inside of that video, I'll also show you the theorem that people think works, but doesn't work, and I'll explain why. I'll see you over there. Thanks for watching this one. I'll see you soon. Bye.